Hello friends, myself R.D. Mahajan presenting my video on inverse Z transform by residue technique. Let us solve the first problem. In this video, I am going to discuss two simple problems. The first one, find inverse Z transform of Z cube divided by Z minus 1 by 2 into Z minus 1 whole square. Here there are two terms in the denominator. Therefore, let f bar of Z is equals to Z cube divided by Z minus 1 by 2. This one is a simple pole, and second one Z minus 1 whole square, a pole of order 2. Therefore, Z is equals to 1 by 2 is simple pole, and Z is equal to 1 is pole of order 2. Pole of order 2 means we have to apply formula 1 and formula first and formula second to find the inverse Z transform. Multiplying it by Z raised to n minus 1, multiplying by Z raised to n minus 1 on both sides, we get Z raised to n minus 1 into f bar of Z is equals to Z raised to n minus 1 into Z cube divided by Z minus 1 by 2 and Z minus 1 whole square. It is equals to, adding the power, we get Z raised to minus 1 plus 3, we get plus 2. Therefore, Z raised to n plus 2 whole divided by Z minus 1 by 2 and Z minus 1 whole square. Then we try to find out the residue at first pole, which is a simple pole, and therefore residue at Z is equals to 1 by 2 simple pole is equals to, as per formula, it is Z minus A, Z minus 1 by 2 into this term. That term is Z raised to n plus 2 whole divided by Z minus 1 by 2 and Z minus 1 whole square at Z is equals to 1 by 2. This Z minus 1 by 2, Z minus 1 by 2 get cancelled, and therefore remaining terms are Z raised to n plus 2 whole divided by Z minus 1 whole square at Z is equals to 1 by 2, and therefore it is equals to 1 by 2 raised to n plus 2 and whole divided by 1 by 2 minus 1 whole square, and it is equals to, splitting this power as 1 by 2 raised to n and 1 by 2 raised to 2. 1 by 2 square is 1 by 4 and whole divided by 1 by 2 minus 1 is minus 1 by 2, minus 1 by 2 square, 1 by 4 get cancelled, and therefore we get the first residue as 1 by 2 raised to n. We call this equation 1. This is the residue at the first pole. Z is equals to 1 by 2, simple pole. Its value is 1 by 2 raised to n. Then we try to find out residue at the second pole. Obtaining residue at second pole, Z is equals to 1. As it is pole of order 2, we have to apply second formula, and as per that formula, it is 1 upon m minus 1 factorial, that is 2 minus 1 factorial, means 1 factorial, and same order derivative, and therefore it is d by dz of Z minus A, Z minus 1 whole raised to m, here m is 2, into that term Z raised to n plus 2 divided by Z minus 1 by 2 into z minus 1 whole square, and after finding derivative, its value at z is equals to 1. And therefore, this z minus 1 square and z minus 1 square get cancelled. We have 1 by 1 factorial is 1. D by dz of remaining term is z raised to n plus 2 and divided by z minus 1 by 2. And its value at z is equals to 1. And then differentiating it by quotient rule, u by v rule, we have z minus 1 by 2. Differentiation of this term is n plus 2 z raised to n plus 2 minus 1, we get n plus 1 minus z raised to n plus 2. Differentiation of this term z minus 1 by 2 is 1 with respect to z, and divided by square of this means it is z minus 1 by 2 whole square. And at z is equals to 1. And therefore, substituting the value of z as 1, we get 1 minus 1 by 2 n plus 2 1 raised to n plus 1 minus z is 1 raised to n plus 2 and whole divided by 1 minus 1 by 2 and its square. And therefore, it is equals to 1 minus 1 by 2 is 1 by 2 into n plus 2. 1 raised to any number is 1, therefore into 1, and minus 1 raised to n plus 2 again 1, and whole divided by 1 minus 1 by 2 is 1 by 2 and its square. And therefore, it is n by 2 plus 1 minus 1 get cancelled and divided by 1 by 4. And therefore, it goes to numerator 4n divided by 2, nothing but 2n. Therefore, the value for second residue is 2n, and then take the sum of that two residues, residue 1 and residue 2. Adding equation 1 and 2, we get. By adding 1 and 2, we get f of n is equal to, first residue is 1 by 2 raised to n, and second residue is 2n. As a required answer. Therefore, the value of that inverse Z transform is 1 by 2 raised to n plus 2n. One more I will discuss. Second example, find inverse Z transform of Z plus 2 divided by Z square minus 2Z plus 1. And therefore, to find its inverse Z transform, let consider that function as f bar of Z. Therefore, f bar of Z is equal to Z plus 2 whole divided by Z square minus 2Z and plus 1. And we can rewrite it as Z plus 2 divided by, it is the perfect square of Z minus 1. And therefore, equating this term to 0, that is, we get Z is equal to 1 pole of order 2. This is the first step. And as it is pole of order 2, we have to apply a second formula to find the inverse Z transform. Next step is multiplying it by z raised to n minus 1 on both sides. Therefore, z raised to n minus 1 into f bar of z is equal to z raised to n minus 1 multiplied by z plus 2 and whole divided by z minus 1 whole square. And therefore, it becomes z raised to n, adding the power, n minus 1 plus 1, we get z raised to n, and plus 2 times z raised to n minus 1 whole divided by z minus 1 whole square. Then, obtaining the residue. Finding residue at that pole, z is equals to 1, which is a pole of order 2, and therefore as per formula, it is 1 by m minus 1 factorial, m is 2, 2 minus 1 factorial, and it is nothing but 1, and same order derivative, therefore it is d by dz, first order derivative of z minus 1 whole square multiplied by this term. That term is z raised to n plus 2 times z raised to n minus 1 whole divided by z minus 1 whole square. And at z is equals to 1 after determining the derivative. And therefore, 1 by 1 factor is 1. This z minus 1 whole square cancel with this z minus 1 whole square. Differentiating this term with respect to z, we get derivative of that first term is n, z raised to n minus 1. Differentiation of the second term is 2 times n minus 1 z raised to n minus 1 minus 1. Therefore, it becomes n minus 2 and at z is equals to 1. And therefore, substituting the value of n as 1, we get it is n 1 raised to n minus 1 plus 2n minus 1 and 1 raised to n minus 2. 1 raised to any number is 1, therefore this is 1, this is also 1. 1 into this n, we get n plus this 2n and minus 1, and therefore value is 3n minus 1 is the required answer, or the value of f of n. Inverse Z transform. This is the value of inverse Z transform as 3n minus 1 obtained by a second formula by a residue technique. In my next video, I will discuss the next point, another important point, that is how to solve a difference equation using Z transform. Like my video, share it, as well as subscribe to my channel. If you are not subscribed yet, please subscribe it, and to receive the notification for my new videos, press the bell icon. Thank you. Thanks for watching.